Good morning, dear students. So today our topic is attacking reagents in a chemical reaction. That is electrophiles or nucleophiles. So how does the chemical reaction takes place? Actually, what are the different driving forces which are responsible for a chemical reaction to occur? There are different driving force, and one of them is the presence of electrophile or nucleophile in the reaction, or we may say the presence of Lewis acids or Lewis base present in the solution. So as a result of which they are acting as a driving force for a chemical reaction to occur. Here the reaction, how does the reaction takes place? It is because of these uh, chemical species. They act as a driving force for reaction to occur. So there are different types of there are different uh, uh, factors which are responsible for a reaction to occur, or a reaction to complete. One of them is the presence of electrophile or electrophilic attack, or presence of nucleophile or nucleophilic attack. So actually, what are the electrophiles or what are the nucleophiles? We will here discuss one by one. So first, let us see the what is the electrophile. So electrophile, actually, the word electrophile means, there are two things you must remember. Electro means electron. So this is electron. Electro means electron. Phile means loving or attracting. So electrophile is any of the chemical species which is electron loving in nature. Electron loving in nature. That is, it needs electrons. It needs electrons, or it is having the tendency to attract the electrons. So actually, the electrophile itself or electron, so electron deficient species. Electron deficient species. So these are actually the species which is having deficiency of the electrons. So that is why these are called electrophiles. That is, they find wherever they find in the chemical reaction or in the substrate, they find there is electron density. They attacks on that of the particular atom, or any of the group of atoms in the substrate during a chemical reaction. So we have here discussed two types of electrophiles are here, which are electron deficient in nature. That is, you must remember that there is a deficiency of electron. That is why they are electron loving. That is why they are electron deficient, means they are electron loving. They need electrons. Clear? So there are two types of electrophiles. One is positively charged, and another is a neutral electrophile. So here we will see one by one. Positively charged or electrophiles. Positively, it itself indicates that positive means this is an electron deficient species which needs, there is a positive center in this atom. As a result, it is electron deficient. It needs electrons either to complete duplet, or either to complete its octet, in order to acquire stability. Actually, whenever you find in the chemical reaction, in there is unstability, the reaction occurs. When there is a stability, the reaction does not occur. So it is because of the instability of this substrate or any of the chemical species which is responsible for the reaction to occur, which is responsible. Actually, the reaction, every reactants wants to become stable. As a result of which, there occurred some chemical reactions. They there occur under some chemical conditions. They acquire the stability, so they get transformed into products. So only those reactants will be changed into products which occur stability. It means that the reaction only occurs, it is due to the instability of reactants which change into the products. So new products with new properties are formed. This is called the chemical reaction. So in every chemical reaction there is instability in the reactivity in the reactant sides, as a result of which is a driving force for a chemical reaction to occur, and this due to this they undergo some chemical change and results in the formation of a new substance, that is product, which is having the new properties. So reactants having different property, product which is occurring, which we are getting having different properties. So from the reactants we are getting the product, from the reactants we are getting the product. So reactants having different property, products having different properties. So this is called as a chemical reaction. Chemical reaction, they actually there is instability in the reactant side and stability in the product side. So every reaction approaches to product side in order to acquire stability. Clear? So this is main thing which is responsible for a chemical reaction to occur. Similarly, you will here see that, so actually what happens in the chemical reaction, there occur there there exists some reactive centers. Reaction centers means, for example, here is a positive charged electrophile. Positive charged electrophile means they are electron loving, so they tends to attack at that atom or group of atoms in the reactant side, which is having the electron rich centers, that this electrophile will attack this electron rich center, and as a result of which they form some chemical bonds, due to which they acquire stability. So this hydrogen positive which becomes reactive, which is unstable, and this is also this, as a result of which this attacks this electron rich center to acquire some negative charge in it and to become stable, then results in the formation of new substance that's called as a product. Clear? So this is how the electrophile approaches towards the reactant, towards the substrate. The substrate or the chemical substance. Substrate means reactants. So reactants mean a substrate where the actually the electrophile having positive charge, which is electron deficient, will attack on this substrate, and this results in the formation of new substance that is called as product. Clear? So here their positive charged electrophiles are, H positive is electrophile because it's having, that hydrogen, it well it is electronic configuration is 1s1. When it loses this electron, it becomes H positive. Clear? So this is how any actually there occur the oxidation of this H positive, which results in the formation of proton. Clear? This proton is highly reactive, and this tends to become stable. So it is having, because it is electron deficient in center now, so it tends to attack at that atom or group of the substrate where there is electron rich center. So this attack at a substrate where there is electron rich center, so this is called as electrophilic reaction. Electrophilic may be electrophilic substitution, electrophilic addition, or electrophilic new electrophilic. In general, you remember that it is an electrophilic reaction. Electrophilic, and electrophiles are attacking to the substrate. Clear? So there are different types of electrophiles. One is H positive. Here, similarly H3O positive. This is also one of the electrophile. Chlorine positive, electron deficient species. Bromine positive, electron deficient species, that is electron loving. Similarly, NO2 positive, this is also electron deficient species. These are positive centers in it, which itself indicates that they are electron deficient. NO2 positive charge means electron deficient. NO positive, carbocation, carbonyl group, it is also a positive charge. Why? Actually, in this case, carbonyl group, it is just like as this. Oxygen is electronegative element. it acquires some negative charge because it tends to attack it tends to pull this shared pair of electrons towards itself. As a result, it acquires the negative charge, so it is electronegative. As a result, it tends to attract these electron pairs towards itself, and this carbon gets positive charge. Clear? So this is called as a carbocation. Clear? So this actually here like this, carbon positive. So this is electron deficient centers are created in case of carbocation. Similar in case of carbonyl group. So there is also the electron deficient centers there. The positive charged species are created. So these are some of the positively charged electrophiles. Similarly, there are some other electrophiles which also acts as electrophile. For example, these are called as a neutral electrophiles. Neutral electrophiles. In neutral electrophiles, there is, although there is no any positive charge, but there is something which you must remember, that for example in case of boron trifluoride. Actually, boron trifluoride, in case of boron is electron deficient because it is having actually if you see the atomic number of the boron. So in case of boron trifluoride, you will see here that boron, it is having atomic number 5. It is first shell contains 2 electrons, second contains 3. Clear? 3 plus 2 get 5. But when we add another 3 fluorine atoms gets attached to this with 1 electrons each. As a result of which, this boron fluoride, we will write that boron is having actually only 3 valence electrons. So 3 fluorine atoms gets attached here. So this is how thin fluoride atoms get attached here. But instead of this molecule, which is a BF3, is formed, but the boron does not acquire the noble gas electronic configuration, or it does not acquire the octet. So you will count the electrons. There are only 6 electrons present in the outer shell. It must have, in order to acquire stability, it should have 8 electrons in it. So as a result of which, due to this the boron atom is lacking of the 2 electrons in it. As a result of which, this boron in BF3 is deficient of 2 electrons. So it is electron deficient. It is electron deficient, as a result of which this boron trifluoride acts as a electrophile because it is electron deficient species. Similarly, AlCl3 is also electron deficient. So these are all electron deficient species. Some, for example, in case of FeCl3, you will see there are the presence of vacant d orbitals. So the vacant d orbitals means they are electron deficient species, as a result of which they act as electrophiles. So electron deficiency means electrophiles, electron loving. So they love electrons. So they need electrons. Clear? So in order to become stable, these neutral electrophiles tends to attract the electrons towards itself, as a result of which they act as an electrophile. Similarly, if you see here the carbene, this is actually carbene. You will see that, and I have already mentioned you that in some cases there is the particular chemical species does not acquire the octet in order to get stability. For example, this carbene, you will see here that there are only 6 electrons in its valence shell. So that as a result of which, it does not have octet, so it is electron deficient. So it has the deficiency of 2 electrons. So in this also acts as a electrophile because it is having the deficiency of the electrons. So this is in both the case, positive charged or neutral electrophiles, there is a deficiency of electron. So they, as a result of which, they are acting as a electrophiles. That's electron loving. Clear? So this is a one that is electrophiles we had discussed. Second thing is a nucleophiles. Nucleophiles means nucleo means nucleus. Yani nucleus means positive charges, positive centers. Nucleus means positive centers. Phile means loving. So these are nucleophiles are actually the electron-rich species. Electron-rich species. Clear? So they tend to attack those species which are electron deficient. For example, where there is a positive charge, there is deficiency. As I have already mentioned in case of the electrophiles. So actually in the chemical reaction, if you see the chemical reaction, there occur two centers. One is a positive center. For example, one is electron deficient center and one is electron rich center. Electron deficient center is called as an electrophilic center, and this is called as a nucleophilic center, because this electrophilic center has tendency to attack the nucleophilic center. Clear? And electron rich center, similarly nucleophilic center will tend to have to attack on the electrophilic center. As a result, these are driving force in the reaction to occur. So in case of nucleo means nucleus, it means they are electron deficient centers, positive charge centers. Phile means attracting or loving. Clear? So these nucleophiles or electron rich species may be either negative charged, they also may be negative charged or neutral, but at least one pair of electrons, but at least one. These are regarded as the Lewis basis. In case of electrophiles, these electrophiles are regarded as Lewis acids. This is your homework. You must go for the Lewis acids. What are Lewis acids? I give you some uh, hints that Lewis acids are electron deficient species which accepts the lone pair of electrons, which accepts the electrons from the outside. So Lewis acids are anything which is electron deficient, which for example any of the cation. For example, we have had positive. This accepts the electron pair, or it accepts the electron pair. So as a result of which this acts as a Lewis acid. The Lewis acid means which accepts the electron pair, and Lewis base is that which gives the electron pair. For example, this is having negative charge, this gives the electron pair to this. So this is Lewis acid and this is Lewis base. So you must go for Lewis acid reactions, and you Lewis, what is this Lewis acid, what is Lewis base, and you read yourself. And this is very easy. You have already discussed, we have already discussed in the previous classes. So so in case of nucleophiles are two types. They may be negatively charged or neutral. Negatively charged means nucleophiles means nucleus loving. They are electron rich species. There is negative charge on chlorine, hydrogen. This is sorry, hydrogen is having the negative charge. So it means that hydrogen negative charge means they are electron rich. Chlorine the negative charge rich. Bromine, they are negative charged species. They are all negative charged species. So these are neutral. These are called as a negatively charged. That means they are what? They are nucleophiles. Nucleophiles means they are himself what? Electron rich centers. So they attack on what center? Electron deficient center. Electron deficient center. So clear? Similarly, here is the neutral nucleophile, but you must remember that in case of neutral nucleophile, they must contain at least one or two lone pair of electrons. For example, in case of water, you will hear that there are two unshared pair of electrons. So it acts as a nucleophile because it has more electrons. As a result, this is the electron rich center. So it will attack on electron deficient center. Clear? Similarly, it is alcohol. It is having two, oxygen is having two unshared pair of electrons. This is ether and this is this is what is this, ammonia. Clear? This is azido, this is tertiary ammonia. So it is actually what they all having the lone pair of electrons in case of neutral nucleophiles. So they act as they are having electron rich center, so they attacks on the electron deficient center. Clear? So in general we will say that in the molecule there is substrate and substrate. On this substrate there is attack of either electrophile either electrophile sorry either this is substrate, and there is a attack of either electrophile or there is a attack of either nucleophile. So this is how that when there is an attack of electrophile or nucleophile, you will see here the reactive intermediates. Reaction intermediates are formed. Reaction intermediates we have already discussed are carbocations, free radicals, or carboanions. So this was all about today's topic. Hope you understand. Clear?